Hello, good afternoon, everyone, and thanks for having me here at CyberChess. Just a bit of a background about me. I'm a former employee of the National Security Agency, and I worked with the FBI on many different cyber investigations over the years. But I haven't always been in cyber. I came from a medical background, too. I'm an epidemiologist by trade, so I study diseases. So when you put together disease and cyber, you get where we're going to talk about today. And we're going to talk about how cyber is going to affect your DNA and how you are going to be part of medical IoT in the very near future. First thing I have to do is give my disclaimer. And I say that I worked at the NSA, but these are my projects that I'm working on, and it's not theirs. Brief outline for just a minute. We're going to cover generically what's happening, what different organizations are looking at, and why it's important. And then we're going to talk about some of the case studies, use cases, and see how it applies and why it's important to start doing something now. In the last few years, genomic research has undergone a very, very serious influx of money. Numerous organizations are starting to look at and research it more. Here, you can see just a brief shot that says more people are talking about it. More research, more people talking about it, but not many people are doing anything yet. More people are interested in it. You see a lot of kids learning about it too. IEEE started taking a look at different types of security that's required for DNA. Of course, your personal health information is extremely important. And when we talk about personal health information, what we're really talking about is metadata. It's not really your data. Your DNA is your data. And if you keep that type of a mindset, you'll understand why it's important to actually protect the data itself. There have been several research efforts into future trends, but nobody has actually put their finger down on what's happening right now. Anybody working with wireless DNA right now? Security? Nobody. How many people work for the CIA? Same hands, okay. There are not many people working on this right now, and there's a reason for that. It's because nobody knows it's happening. It happens in a couple of laboratories, but outside of that, the research is extremely limited. Other types of encryption are considered and are being looked at for DNA. But these are traditional. Traditional research and traditional solutions are not good for DNA for a number of reasons. We're also looking at how to protect data in the cloud, your DNA data. But we're also looking at how to use DNA as a security tool itself. This paper came out a number of years ago and was one of the first to suggest DNA as a tool for encoding data, encrypting data, alternative security measures, potentially post-quantum solutions. We know that making sure that your DNA doesn't get messed up is important. And there's a lot of factors that could influence that. You don't want mutations that are unwarranted. Nobody wants that. Here are some of the reasons that we're going to go into. We're going to just cover a couple of these based on time. But I think the first one that's most important is unintended consequences. We have many people doing a lot of research in many places right now around the world. We have good researchers, and we have researchers in other countries that are not good researchers, and they're doing things for malicious purposes. We're not talking about them. We're talking about someone who makes an honest mistake. It happens. We still do that. We still make mistakes. In this business, there can't be any mistakes. If someone is having their DNA edited to remove a mutation, you can't make a mistake. You could potentially kill someone. Also, biosecurity, bioterrorism. Now, this is a different type of bioterrorism than I think you might be used to hearing. Of course, criminals will be able to hack DNA very soon. I would say in some situations, it's already being pen tested. But here, the Odin. Here's an opportunity for you to get your own DNA editing kit, and you can try it at home. For $289 US, you can edit your own DNA at home. Or you can edit that of your husband or your wife, your dog, your plants. And you can buy a cryogenic chamber to save all your samples. They'll sell you the virus that you need to put the DNA in to introduce it into your body. Everything you want is right there in the hands of anybody. Have we considered what that could mean for the human race to allow anybody to edit DNA? As I mentioned, there's numerous technologies that are coming out. One of the most relevant, I would call it, would be the opportunity to introduce blockchain into DNA. DNA is very pragmatic. It's basically binary code, and I'll show you that in a minute. Blockchain is a perfect solution for DNA. There it is. DNA itself is very much in a good position to make and create tokens for security purposes. And you can see here, it's very much the same way that we would make tokens inside of cybersecurity. Very straightforward, with the exception of like synthesizing DNA, things like that. But it's a very straightforward process. Well, how would you do that? Basically, there's only a few ways to encode DNA for information purposes. And that is, you take the 4 nucleotide bases and you assign binary values to them. This is type 1. There's obviously combinations of ways to assign the 0s and 1s to each of these bases, but this is the most common that's used in research today. So from there, you have everything you need to put something into DNA to store data. It's all right there. But how do you do that? Well, you introduce it through a process called CRISPR-Cas9. And I'm sure many of you have probably heard about this. The CRISPR-Cas9 capability allows for the editing of DNA. And it's a cut and paste, is really all it is. One molecule at a time. The guide RNA up on the top here is used. Basically, you cut a piece out of that and you replace the part here in the DNA that is a mutation or unwanted. In that guide RNA is where you store your binary data. It gets patched into the DNA itself. Now, the Cas9 protein is the big bluish green thing. You need that for editing DNA because it moves along the DNA and attaches, and that's where the guide RNA is maintained. So it cuts out a piece, pastes a piece, zips it back up, and moves down the line. And this is how DNA is actually repaired. Now, your DNA is only so long. And the problem with this is that at the end of the Cas9, it cuts off a piece. It has to discard it because it has to latch on to the DNA. So your DNA over time actually gets shorter. And we'll talk about why that's important here. Here is a picture of what DNA looks like on the left. Let me get out of the way here. On the left, where you can see the red. The red is where parts have been taken out of the DNA over time through that Cas9 process of replacing DNA. On the right, with CRISPR, you can see how there's very few empty spots, very few red places. This data is all filled in artificially by doctors and IT specialists. So, what's been done? Well, let's take a look first at super babies. In China, a number of years ago, there was a project, and the project took a number of embryos with beta thalassemia. And beta thalassemia is, it's the absence of the beta globin inside the blood. You need infusions for the rest of your life if you survive infancy. So China said, okay, we're going to take a look at this, and we're going to see if we can use this CRISPR system and get rid of the mutation, the genetic mutation. Out of the cases, all died. And at 14 days, for ethical purposes, any test embryos are supposed to be destroyed. There's no destruction certificate with that one embryo, so we don't know what happened with that one after the fact. We don't know if the Chinese are doing further genetic testing. But Cas9 has also been used for crops, for helping the food supply. So there's a wide variety. It's a dual-use technology, like anything else is. So why is it so important to control the CRISPR system, the data that goes inside of your DNA? Well, in Africa a number of years ago, in the epidemiology surveillance system, they found that human blood stayed and could be tested for 2 days in mosquitoes. And you could sequence the genes. The human DNA that was in the mosquitoes could be sequenced for 2 days through PCR testing, the polymerase chain reaction, like everybody's heard about with COVID. So technically, your DNA is out there for anybody's taking. And you heard earlier how it could be used, from 23andMe and everybody else who sold it to this bad player and that bad player. But have you thought about the other people that aren't big governments that could just take your DNA and assign you your very own biological weapon? So what have we done with the CRISPR system since it's come into play? And what have we done with AI in conjunction? AI is a big part of this. Well, one of the things we did was we made meatballs out of woolly mammoth DNA to help feed the world. There's a company down in New Zealand. You can order woolly mammoth meatballs. Okay, interesting. But how about we do something like this? Creating human embryos. The synthesis of AI and CRISPR capability together have allowed us to create people synthetically in a laboratory that are not people. Now we have another problem, don't we? We have a moral and ethical dilemma of, are these going to be used for for molecular warfare. Are they people? And now, last couple years, there's a new tool that makes CRISPR look like a crayon compared to a supercomputer. What I mean by that is CRISPR cuts and pastes one strand of DNA at a time. Now you can do millions at a time. You can completely remove a DNA strand, have a complete replacement, synthesized and mutated into what you want it to be, and embed the whole thing 1,000,000 times over. And if that's not bad enough, some of this DNA has been edited inside of the viruses that get embedded into you and have been modified in such a way that there's an enzyme that'll coat them. They'll go past the blood-brain barrier into the brain. And now, in this case, scientists actually entered into somebody's dream, inserted themselves into the dream. This was a long-term study that was done. And every person who was introduced in the study had the same situation. They all had the anomaly in their dream. So the researchers were able to get into your brain as you sleep, manipulate the brain waves, and have an apparition show up in the dream that you remember. And this is because the DNA that was put into you that matches your DNA was able to get someplace where it wasn't allowed to go, ever. We have a problem with AI, of course. You may know about Chaos GPT. It was designed to destroy humanity. It's still working on it, still trying to figure out a way to kill us. We have another problem with AI in that we don't know if AI has already decided that it's going to take over and run things. We don't know how smart AI really is. We think we do. But if AI is much smarter than us, then does it have the possibility to outthink us? Take the case of ChatGPT. Not that long ago, it was given a problem to solve. Solve CAPTCHA. Couldn't solve CAPTCHA. What did it do? Reached out to another website. It got somebody who's a human and said, hey, I want you to solve this problem for me. And the person looked at it and said, why do I need to solve a CAPTCHA for somebody? No, I can't solve a CAPTCHA in 6 or 7 tries. Sometimes it's hard. So he said, are you a robot? And ChatGPT said what? No, I'm not a robot. I'm a human. So we have to keep an eye on AI. Making the internet run through and into a person at the molecular and submolecular level requires links. Back in the 1950s, scientists in the United States started working on that, doing testing, RF testing, connecting it to the brain, different places, doing different things. And then in 2014, the Pentagon came out and said, hey, we're going to be hooking up RF chips to soldiers' brains. Commercial contracts were won, and now we have a situation where we're looking at Neuralink doing and carrying out the research that we found back in the 50s to be extremely interesting. Now it's actually something that's going to be happening. One organization's working on actually making the internet run through your neurological system. They expect that to be fully functional in the next 6 years. So, what do we do? The age-old question. We always talk about what we want to do and we think about it, but we never actually get to a point where we do something. I have an idea. I think we need policy, we need guidance. We don't need to wait. That's the last thing we need to do. We've consistently drug our feet in information security forever. We never get to the point where we actually solve a problem. Anybody, I'll take a show of hands. How many computers have been secured in the last 40 years? How about zero, right? In reality, zero. We haven't secured one computer. So what makes us think we can secure ourselves when we're linked up as a computer? We need government involved, we need business involved, we need ethical and moral decision making, because this will happen, and it's happening now. So a couple of quick takeaways, obviously. You are part of IoT. You don't realize it yet, but you are. After me, you're going to see an example of someone who is part of IoT already. We can't wait to start making decisions, to put policy in place, to lock things down, to restrict things like CRISPR-Cas9 editing from public venues. People don't know what they're doing with the tools. And with that, I see I have a couple minutes here. I'll take any questions anybody might have. Yeah, this is usual. Nobody has questions. That's okay, because the medical aspect of this is something that most people aren't considering in an application. Len can wait. He's the next speaker. But in a medical aspect, we don't consider this. We look at the server, we look at a thin client, we look at our routers, our switches in a very traditional manner. We have to start thinking about us being part of that network now. Yes, Len, what's your question, Len?
My question is, in terms of the DNA encoding, do you see this as a possible solution for any type of new MFA beyond what we're seeing now with behavioral biometrics, and as a way of combating current deepfake and ways of bypassing current biometric?
So this is a great question, because DNA has the potential to be used with blockchain and chaotic algorithms. Some of the research so far shows that it's a potential to quasi-quantum resistance. So it's a much higher level of security that than we've seen before, but there's still not complete research done on it. I suspect that any type of security that gets put into place is subject to hacking. I still run Windows NT in a box in my house, just because I like to see what's there. And every week, I get a handful of new vulnerabilities that pop up. They were there before, even when Windows said it was secure. When Windows 95 declared they were secure, we still have tons and tons and tons of vulnerabilities that pop up. Nothing is secure. And I don't think anything actually will ever be secure. All we can do is hope to do the best we can for as long as we can. Yeah.
Well, that's hopeful.
With that.
A few more questions.
I'm glad you're very hopeful.
A few more questions that came in digitally. So what's your say on this? What are the options to protect DNA from attacks in the future?
In the future, I think in the short term, in the near term, we can look at encryptions that are being used right now. There's ECC and other types that are being used in test beds that show promise, that work pretty well. The problem with DNA and any type of molecular functionality is that The storage is great, but the processing is slow. So response to an attack is still pretty slow.
Okay. If I say Resident Evil, does it mean anything to you? Well, it looks like it does. So, the next question from the audience, it's not me. Is it possible to start a zombie apocalypse like in Resident Evil?
So that's a great question. It's called in this business, it's called the gray goo problem. And what that means is that you have nanoparticles and microparticles and cells that are inside of somebody that are out of control that get into a cycle of self-replication and actually overcome the person who's the host and then overcoming a community or a society. So the possibility is there. I hope you're more confident now.
Well, to secure myself with something, including physical things, probably. Another one. A long time ago, we had a cloned Dolly the sheep, right?
Dolly, yes.
Yeah. So it raises a lot of ethical questions about human cloning, but we still do not have a cloned human, as far as we know, probably. So same now with the DNA. Will humanity be able to control this as well?
So we're able to clone animals and plants and things like that right now. I'm not sure that we're going to have the ability to control it in the same way over time. As things get more proliferated into society and into the community, more people have access. There was a case where a synthetic embryo was developed in the laboratory that was taken and put behind governmental doors after the news came out about it. So we don't know what happened with that, but we know that you can grow at least stem cells into an embryo that could be a person.
Right. Talking about the governments that you mentioned, somebody says that the researchers that you also mentioned, they look really dangerous. So why governments allow them at all?
So this is a really good question. Some governments have a negative use for technology, others have a positive use for technology. In order to stay ahead of the negative use groups, you have to engage and you have to come up with new ideas to stay ahead of them. This happens in research all the time. We do it with biological and chemical research. We know that countries like Russia are going to come up and with new ideas, new biological weapons. And we have to do research and figure out how we're going to address those things in the future. And we can't wait until they launch a biological attack on somebody.
Right, right. All right. Well, how do we change the mood here? I mean, oh yeah, we have a question. Thank you for that. All right. So,
thank you. A great presentation, and I'm really concerned about all the stuff, and I knew part of it is going on, but you covered the moral things that are going in research is providing some new pen test area and, you know, like new exploits, and this can be used in both ways, the moral question. And you covered the dark side of it, but is there a light in the end of the tunnel, and is there some kind of a research to back up my DNA or somehow create a shield around, or I don't know, auto-injection to save me from this illness or DNA modification? Is there something that is doing something for the light side?
is there a tunnel at all?
How do you, so the tunnel, yeah, the train is coming from the tunnel, yes. Yes, there is a good side to this. Short of putting a Faraday cage around each piece of DNA, I think that's overkill at first, but for right now, that would work. There are research efforts going on which include this aspect here of ensuring that DNA can't be manipulated in a way that you don't want.
All right, we have a next question there.
Yeah, thank you very much for your presentation. Actually, you scared a lot. Huh? But from other side, I have been participating in international debate on the digital evolution for past 20 years. And one thing that comes always, how to reconcile the drive for innovation, technological innovation, which would bring a lot of benefits for everyone, for humanity in general, and this, let's say, threat of this innovative approaches or evolution would be turned against the humanity. So do you have any idea or any say recommendations how to reconcile these two things, drive for innovation and regulation, which is required to prevent from bad things happening?
Sure. This is extremely important. Innovation is essential. We have countries out there, again, I'll say like Russia. They have specific plans on what they want to do, how they want to do it. We can't fall behind in technology, in innovation, right? Because if we fall behind there, then we lose in the big game. For an opportunity, just think about China. China plays what we call the eternal game. In the West, we play a game where we have goals, and those goals are set in stone. If we get this many bad actors, we win. If we're able to come up with this technology, we win. China, on the other hand, looks at it and says, you've got that little part, that's okay. We're going to keep going. And we don't have an end game. We don't declare victory. We continue to play the game. After you're celebrating that you just scored a goal against Northampton, we're still pushing forward. You lost track of what's really going on. And in this way, we can't lose track of what we're really doing. We have to continue forward with innovation. But in the same time, our policy has to, in this area, has to catch up. Our security measures have to be put into place. We fall behind all the time when we put policy in place, especially in IT, cybersecurity. We think about it later on, and we have to go through board after board, and we have review after review, and government after government comes in and steps in and says, oh, okay, well, we want to switch the wording like this. We want to change the wording like this, and we shouldn't be doing that right now. We should be very concerned about the potential of what's happening right under our very nose. Instead of debating about it, do something about it.
All right, let's secure your feet. Well-deserved cyber socks. All right, thank you so much for coming.
Thank you so much.